All right, now we're moving on to the second question for the AP Calculus BC 2024 free response test. This question involves a particle that is moving along a curve in the xy plane, and they give us information about x prime of t and y prime of t, so the derivatives of the x of t and y of t respectively. And the initial condition that they give us is that at time t is equal to 2 seconds, so we're measuring time in seconds, the particle is at the point 3,6. So we know its position at t is equal to 2. So let's go through this part by part. So first, part A, it's asking us for the speed of the particle at time t is equal to 2. So we know the speed, we can actually write a s of t function for it. This speed is just going to be the square root of x prime of t squared was plus y prime of t squared. Let's extend that radical symbol out. And since it's asking us for the speed at 2, so s of 2, and we're just going to plug in 2 into what we've set up already. And since it is the calculator portion, we just want to show our understanding of what it is exactly that we're entering into the calculator. But from here, you should get it that it's approximately 12.304 if you are truncating, or 12.305 centimeters per second if you are rounding. Okay, so centimeters per second. That is the speed at which this particle is moving. All right. Now, part B. Part B then is asking us to find the total distance traveled by the particle from 0 to 2. So same interval, but from total distance. And what we essentially have is just the length of the curve from 0 to 2 of s of t. So we're integrating our speed function that we came up with in part A, and we integrate that from 0 to 2, and what you should get is about 15.901 if you are truncating, or 15.902 if you're rounding centimeters. So that is the distance traveled by that particle from 0 to 2. All right, so pretty straightforward start. Part C, we're going to find the y-coordinate of the position at the particle time t is equal to 0. And I'm going to actually highlight the fact that it said t is equal to 0 there, because that does come into play. And we're going to show the setup. So part C, we've got y of t, which is what we're going to try to use, what we're going to use to find the y position, right? So at time t. And it's important for us to know that the initial condition we're given is y of 2. But we're going to integrate now from 2 to some, we're setting up the integral first. So we're integrating from 2 to whatever t is, right? And since t is going to be used as our bound, we're going to write our integrand in terms of x, okay? And so we're using what we've just set up now to find y of 0. So we're plugging 0 into what we've just set up. So y of 2, we know that our y position, and if I just go back to this, our y position was 6 at t is equal to 2. So we're going to put that in here for y of 2. And then our integral is going to be from 2 to 0. And you're not reading that wrong. We're actually going to be integrating right to left, right? And so since this is the calculator portion, you don't have to worry about switching around that integrand and making it negative. We can just set that up as is. So take what we have for y prime of x, integrate it from 2 to 0, and then add 6 to it. And we can see that when t is equal to 0, we're actually at negative 1.1736 centimeters. Okay? So in other words, when t was equal to 0, our y value was actually lower. So as time elapsed, it actually moved up to y is equal to 6. Now let's look at part D. Part D is then saying, so from 2 to 8 seconds, right? I believe, yeah, we're in seconds. From 2 to 8 seconds, that particle remains in the first quadrant. So it started out when t is equal to 0, below in quadrant 4. From 2 to 8, it's saying it remains in the first quadrant. Find all the times in the interval when the particle is moving towards the x-axis. So just kind of visualize this for a second. If we are, and again, you didn't need to sketch this on the exam, but what they're essentially saying is that our particle is going to remain in this quadrant 1. So find all the values of t where this particle is moving down towards the x-axis. So how would this be moving down towards the x-axis? In order for that to happen, we would have to understand that, so let me write this, for the particle to move towards the x-axis, y value must be decreasing. Okay? That's for the particle to be moving down. So what we're looking at then is, when is y prime of t going to be negative? When is this going to be negative? Well, so we would then plug y prime of t into our graphing calculator, and I'll do this in a separate color so as not to confuse this with what I had previously, but if I graph this in a graphing calculator, plug y prime of t, and we're looking just at the interval from 2 to 8, we see that our function, or y prime of t, is actually going to cross the x-axis at this point right over here, which we would see would be about 5.2218. Okay, so we can say that y prime of t then is going to be less than 0 for all of our t values from 5.2218 up to 8. So the interval that we would say y prime of t is less than 0 on the interval 5.2218. We're not including that because it's 0 at that value, up until 8, because that's what they're asking us about. Okay, so that's what would have to happen for a particle in order to be moving down towards the x-axis, right? Y prime of t would have to be negative.